Welcome to the deep dive, where we take a stack of sources articles, internal research notes, and boil it all down into the knowledge you need fast.
Mm,
Today, we're getting into a really classic problem for any manager. We're talking about mixed costs.
right. It sounds like this, abstract accounting term, but mixed costs are absolutely everywhere. They're just expenses that are part fixed, they don't change, and part variable, so they scale up and down with your activity.
Yeah, and the best example from our source material is the electricity bill for, say, a car manufacturer. That bill isn't fixed like rent, but it's not purely variable like the steel for each car either. It's mixed.
Exactly. You've got a fixed cost just to be connected to the grid, and then a variable cost for every hour the machines are actually running.
And if you can't split those two apart, you're flying blind.
Totally. A manager can't confidently answer something like, what's our total cost if we ramp up production by 20%?
Or even, what price do we need to charge just to break even?
That's why this is so critical. It derails that whole cost volume profit analysis, the CVP analysis.
So the goal for this deep dive is pretty simple. We want to equip you with the two most accessible tools for splitting these costs. We're looking at the high-low method, which is the fast, objective one.
And the Scattergraph method, which is more visual and gives you the whole picture.
Right.
And it's really vital to frame this correctly from the start. Both of these tools, they're just estimates. They're the starting point. They build that conceptual foundation before you commit to a full-blown statistical regression analysis. They give you actionable insight, not the final absolute truth.
Okay, let's unpack that. Let's start with the high-low method. I kind of see this as the ultimate managerial shortcut. It's super fast, it's mathematically clean, but, well, it feels a little risky.
It is. That's its nature. A high-low method just draws a straight line using only two data points, the ones with the highest and lowest activity levels.
So it just assumes those two extremes define the entire cost behavior.
For that operating range, yes.
All right, let's run the numbers from our car manufacturer example. The activity here is direct labor hours.
And we have to be really careful here. You isolate the months based on the activity level, so the hours, not the dollar cost.
That's a critical distinction.
It is, because the month with the highest cost might have just been an outlier, like a big repair bill or something. We need to look at the activity first.
Okay, perfect. So looking at direct labor hours, our low point was in February. That was 6,000 hours, which cost $60,000 in electricity. And the high point was May, 18,000 hours for a cost of $120,000.
And every other month of data, we just ignore it.
Gone. Okay, so now we calculate the variable cost per hour, the slope of the line, right?
Yep. The classic rise over run formula. The rise is just the change in cost.
So it's $120,000 minus $60,000. The rise is an even $60,000.
And the run is the change in activity in the hours.
18,000 hours minus 6,000 hours. That's a run of 12,000 hours.
So you take that cost change
So the $60,000.
and divide it by the activity change.
The 12,000 hour, okay, so $60,000 divided by 12,000. That gives us a really clean number. Exactly $5 per direct labor hour.
That's your variable component isolated.
Feels very clean, so now we can back into the fixed cost part.
Right. The logic is simple. Total cost is fixed plus variable. So fixed has to be total minus variable.
Let's use the high point data to figure that out. The total cost was $120,000.
Hmm.
And the variable part would be the 18,000 hours times our new rate of $5 an hour.
Which is $90,000.
So if you subtract that $90,000 variable cost from the $120,000 total, you get a fixed cost of exactly $30,000.
And that's the cost you'd incur every month, even if the factory was completely dark.
And just like that, we have our predictive equation. Total cost equals $30,000 fixed, plus $5 times your direct labor hours.
Very satisfying mathematically.
It is, but I have to challenge it. It just feels too neat. Throwing out 10 months of data seems almost irresponsible. Are we just picking speed over, the actual truth?
And that is the core risk. That is the huge limitation of high-low. What if May was an outlier? Maybe there was a surprise utility tax that month.
Or February had a weird maintenance dip that isn't typical.
Exactly. A single one of those points can completely skew the entire line. That $5 rate might not represent typical cost behavior at all.
So it's objective in its calculation, but the result might be totally biased by one weird month.
Precisely. And that worry is exactly why we need the Scattergraph method to act as a counterbalance.
Okay, so this is the other side of the coin.
Right. It's fascinating because we go from something that's mathematically objective to something that is visual, holistic, and inherently subjective.
So instead of ignoring the data, The Scattergraph plots every single historical data point.
Cost on the y-axis, your direct labor hours on the x-axis. And you get this cloud of points.
The power here is the visual insight, I guess.
It is. You don't need a math degree to look at that cloud and see a general trend. You could
Okay.
spot if the relationship is even linear.
And you can visually spot those outliers, the ones Hilo might have blindly used.
That's the key. Then once it's plotted, the analyst just visually fits what they believe is the best straight line through that data.
Like drawing a line of best fit by eye.
Exactly. And that line becomes your estimate.
Okay, so let's look at the results for our electricity data using this method. Remember, Hilo gave us $30,000 fixed and $5 of variable.
Right. So for the scatter graph, the fixed cost is where your line crosses the y-axis. It's zero activity.
A y-intercept.
And in the source material, the analysis determined that to be about $40,000.
Whoa, okay, so right away that's $10,000 higher than the high-low method.
It is. And then to find the variable cost, we calculate the slope of this line using any 2 points that fall on the line itself. And that calculation gave a variable cost of $4.29 per hour.
So the Scattergraph equation is total cost equals $40,000 fixed plus $4.29 the hours. That's a really different view of the cost structure.
That's a key observation. Notice the trade-off. Because the fixed cost is higher, at $40,000, the variable rate has to be lower to balance things out across the data.
One model says fixed costs are the big driver, the other says variable costs are.
Yep.
So now we can use this for prediction. If a manager asks, what's our cost for 15,000 hours?
We just plug it into the Scattergraph formula, $40,000 fixed plus 15,000 hours times $4.29.
Which gives you a variable cost of $64,350.
Add that to the fixed cost, and your total predicted cost is $104,350. And that's why we do this, turning history into a forecast.
But that subjectivity problem is inescapable, isn't it? If I'm the analyst, I might tip the line up a little. My numbers would be different. It feels more like art than science.
And you justify it because you're using human judgment to filter out the noise, the visual outliers. You're trading that mathematical certainty of 2 points for what you hope is the representative accuracy of the whole picture. Another analyst might get $31,000 fixed and $4.25 variable, sure, but for a preliminary estimate, that's usually close enough.
Okay, let's put these two competing views side by side. This is where it gets really actionable.
For our electricity example, we have 2 different stories. High-low says $30,000 fixed, $5 variable.
And the Scattergraph story is $40,000 fixed and $4.29 variable.
Right.
That's a $10,000 difference in fixed cost. If I'm a manager, that makes me nervous. Let's test them. Let's predict the cost at 10,000 hours.
Okay, High-low predicts $30,000 plus $5 times $10,000. That's a total of $80,000.
And the Scattergraph predicts $40,000 plus $4.29 times 10,000. That's $82,900.
So the difference is only $2,900. That's about 3.6%.
Okay, so that's not so bad.
Not at all. For a quick quote or an initial budget, that variance is usually fine. It's the 80-20 rule. 80% accuracy now is often better than 100% accuracy 3 weeks from now.
But this is where it gets really interesting. What happens when they don't line up like that? Let's pull in that second practice problem from the sources, the one about monthly production data.
Ah, yes. In that data set, the estimates were much, much farther apart. The high-low method gave them $328 in fixed costs and $24.29 variable per unit.
Okay.
But the Scattergraph estimated only $150 in fixed costs and $26.88 variable.
Wait. The high-low fixed cost is more than double the Scattergraph estimate. $328 versus $150. That's a huge divergence. Why?
This is the perfect example of the danger of high-low. The problem was those extreme points. In that data, the low month was only 40 units produced. But anyone looking at the Scattergraph could see that normal production clustered between 45 and 70 units.
So that 40-unit month was a clear visual outlier. Maybe the plant had an emergency shutdown that month or something.
Exactly. Something not typical. And because high-low is mathematically forced to use that distorted 40-unit point, the line it draws is less steep than the real trend.
I see.
And to make up for that, the math has to artificially push the fixed cost estimate way, way up to $328. It's a distortion from one bad data point.
Whereas the Scattergraph lets the analyst ignore that outlier and draw a line through the real cluster of data.
And that line better represents typical operations. It's steeper, which means lower fixed costs, but higher variable costs. The visual method won because it allowed for business judgment.
So this is the big managerial takeaway then.
This is it. Stop asking which answer is correct and start asking, what does the range of estimates tell me about my costs?
You're using it more as a risk assessment tool. The range itself, knowing your fixed costs, is probably somewhere between $150 and $328, is really valuable for planning.
Precisely. You use both methods to understand the potential variance. The goal is the same. Separate the costs so that when a manager asks, what if we scale up, they can confidently bracket their estimate using both models.
Which leads to better planning, more accurate budgets, and smarter pricing.
Right. So to summarize the utility here, high-low is your objective quick snapshot. It's fast, but it carries that risk of being skewed by outliers.
And the scatter graph is the full picture. It's better for understanding the overall behavior and spotting those anomalies, letting you use your judgment.
Our practical recommendation from all this is simple. Start with high-low for a quick check.
But then use the scatter graph to visualize and verify.
And if the results are wildly different, like in our second example, that's your red flag. It tells you there's an outlier issue you need to investigate before you make any decisions.
Which leads us right to our final provocative thought for you. We've been talking about both of these methods as approximations. They're really laying the groundwork for the most accurate method of all: statistical regression analysis.
That's the next level up. When the difference between your high-low and scattergraph estimates gets too big to ignore, when that 3.6% gap widens to 15 or 20%, that's the signal.
That's when you know you need to invest in a more robust method?
Exactly. Statistical regression uses every single data point to provide a mathematically objective result with confidence intervals and everything.
It's the ultimate tool. But high-low and scattergraph are how you build the intuition to know when it's time to call in the big guns.
At the end of the day, the goal isn't just to calculate the costs. It's to understand what they mean for the future of your business.
That's our deep dive for today. Use these tools wisely, and you'll know exactly what those mixed costs are hiding.